Okay, now we're looking at finding arc measures. We're going to find measures of central angles and arcs. A central angle of a circle is an angle whose vertex is in the center of the circle. So this right here would be a central angle right there. Angle ABC is a central angle of circle B. An arc is part of the circle. So this piece right here is the arc. A semicircle is half of a circle. So from here, this would be half of a circle. Or we could go straight across. This would be half a circle. Or this would be half a circle. Semicircle. A minor arc is anything smaller than a semicircle. A major arc is anything larger than a semicircle. A minor arc is named by its endpoints. A major arc and a semicircle are named by their endpoints, but we need one other point on the arc. So let's talk about some minor arcs. Okay, so 5 minor arcs in circle O. We could go from B to C. This would be a minor arc. To represent a minor arc, we're going to put a little arc over BC. We also could do CD, or you could call it DC, either one. We could combine those two and have BD be a minor arc. We could go from A to B for a minor arc. We could also go from A to D for a minor arc. Could say DA as well. Now, major arcs are bigger than a semicircle. So let's go actually do number 3 and do our 2 semicircles, and then we'll do our major arcs so we can see bigger than a semicircle. So half a circle would be here. Now we are not just going to say AC, because if I just say AC like this, I don't know, are we talking about this semicircle? Or are we talking about this semicircle? We need to add in an extra letter so I know which side of AC I'm talking about. If I'm doing this side, I want to add in the extra B so I know which side. A, B, C with a little arc, and that is talking about the piece of the circle from A to B to C. Now the other semicircle, I could also on that last one say CBA. That would be the same semicircle. So let's do this bottom half. I don't want to say CA or AC because again, I don't know which side of the circle I'm talking about. I have to add in this D letter. So we could say CDA, or we could say ADC with our little arc above that to represent the piece of the circle. Now, arc measures, the measure of a minor arc is the measure of its corresponding central angle. So the measure of this length here, we represent by this angle here. The measure of every circle is going to be 360 degrees. The measure of a major arc is the measure of the related minor arc subtracted from 360. So if I have the whole circle is 360 degrees and the minor arc is 60, the rest of the circle is 360 minus 60 degrees. So this would have 300 degrees for the rest of the circle. The central angle would be here, and the minor arc would be this portion of the circle. It would be represented as 300 degrees. The measure of every semicircle is 180. So it's a straight line. Half of this circle is 180. The other is 180. They add together to be 360. Okay, arcs. Now remember, to find the measure of the arc, it's like we have a center. Well, we have a center. It's whatever angle we have here, that is the measure of this piece of the arc. If I have two pieces right next to each other, if I want to find the whole piece, I just add up AB plus BC. Just add them together. So let's find the measure of each arc. So the measure of AB. So we are talking, what is the measure of this arc? Well, it's going to be the exact same as this corresponding angle. I have half a circle here, which is 180 degrees. Right next to it, I have a 90-degree angle. If I take 180 degrees and I minus 90 degrees, this is also a 90-degree angle. So I'm just going to put a little 90 equals 90 degrees. But it's how we measure this piece of the circle by its angle here. Okay, the measure of CD. CD is this piece here. We need to figure out what this angle is. Every half circle is 180 degrees. I know that this piece right here is 42 degrees. So if I take 180 and I minus 42 degrees, that will give me the measure of CD. That will be 138 degrees. Now, if I'm trying to find from A to C, I can use this arc addition postulate. I know this is 90 degrees and this is 42 degrees. So if I add those two arcs together, it will be 132 degrees. Now I'm going from A to D to C. A, D, C. I can use my arc addition postulate. This is 90. I also know that CD was 138. So if I add 90 plus 138, that's going to be 228. And the last one, ABD, ABD, I know this piece is 180, half a circle is 180. This piece is 90. If I add those together, I get 270 degrees. Now, you may have done this a different way. You might have said, hey, I know, I'm trying to get all of this. I know every circle has 360 degrees, and I have 90 degrees in the piece that I don't want. I also could have said 360 minus 90 degrees, and that also gives you 270 degrees. So you may do it a different way than I do, and that's okay. There's lots of different ways to add these up. Okay, number 5, we are going from S, we're finding the arc S to R. I need to figure out what this angle here is. I have half a circle here is 180 degrees, but I do not want this piece, this 85 degrees. So I'm going to take 180 and minus off 85 degrees, and that leaves me with 95 degrees for the rest of my circle, or rest of SR, or for SR. Okay, now measure of QTS. Going from Q to T to S. Half a circle, easy, 180. QSR, starting with Q, going to S, ending with R. Now, this is the majority of this circle. I want all of it, but I do not want this 85 degrees. So I know that I have 360 degrees. I minus off my 85 degrees. That gives me 275 degrees. RTQ. We start with R, T, Q. I have all of the circle except the 85 degree. Now notice RSQ is exactly the same thing as RTQ. So I really don't have any math to do except to write 275 again. Okay, R to T. Well, I know I've already found SR. It was 95. I already know they give us ST is 22. To find RT, all I have to do is add up 95 plus 22, and I get 117 degrees. Okay, let's look at some theorems. Two circles are congruent if and only if they have the same radius. So if they have a radius is the same, every circle will be congruent. Congruent angles theorem. In the same circle, or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. But they have to have the same radius. So this angle and this angle will be the same because they will have the same measure because they're vertical angles. So these are going to be, these arcs will be the same here because their central angles are the same. And the last one is every circle is similar to other circles. Okay, so let's look at what is the similarity transformation that maps P to C. Okay, so first thing I need to do is I need to take this circle. I'm going to start by making a circle. Trace this. I'm going to move this circle onto this other circle. So first thing I need to do is I need to translate it, which means I just move it around. Then what I need to do is I need to take this circle and I need to resize it. So I'm going to take this and I just need to make it so it's bigger, but it's moving when I'm doing that, it's moving it. So if I make it just a tiny bit bigger, I think it will map. So then I need to just translate it, and then I'm going to dilate it to make it bigger. Okay, what is the ratio of the circumference to the radius of all circles? So radius or circumference is 2 times pi times the radius. So what's the ratio of the circumference to the radius? So if I were to take and divide both sides by r, circumference divided by the radius of every circle is 2 pi. So this would be my scale factor. Is 2 pi. Every time you take a circumference and you divide it by the radius, you will always get 2 pi for every circle, and which shows that it is similar because it's proportional to each other. So